we as pediatricians need to be cognizant of that and really think through, does this patient really need antibiotics now or not? Of course, like I said, there are times when you absolutely need to be on an antibiotic and there's no question. But there are other times when you might say, let's see where it goes.
Inside each of us is a complex, evolving ecosystem influencing everything from immunity to inflammation to long-term neurologic health, our gut microbiome. The choices made early on, such as how babies are born, fed, and treated, can have lasting effects. In this episode, we are exploring one of my very favorite topics, the pediatric gut microbiome, what builds it, what disrupts it, and why it matters more than some may think. This is Charting Pediatrics. To discuss this important topic, we are joined by two senior pediatric gastroenterologists and partners of mine, Dr. Jaime Belkind-Gerson and Dr. Ed DeZoeten. Dr. Belkind-Gerson is the director of the Neurogastroenterology program here at Children's Colorado. Dr. DeZoeten is the director of the Pediatric Inflammatory Bowel Disease Center here at Children's. Both are professors at the University of Colorado School of Medicine. Jaime and Ed, welcome to the podcast. Welcome back.
Thanks so much.
Great to have you guys on. Let's start with you, Jaime. Tell us, what is the pediatric microbiome and why should we care about it?
Well, we have been learning over the last several years that it is essentially like a new organ living inside our body. It is composed of billions of microorganisms, bacteria, viruses, and fungi that live within us, mostly in our gut, and that play very important functions within our body. It's a symbiotic organism. People love to say, but it is striking that if you took all our DNA, there is more DNA that is non-mammalian than mammalian or human DNA. So they are very abundant. And these microorganisms communicate with our body and alter our bodily functions. So they are not only necessary, they're actually essential. We need them. And they have become a source of great importance because they may lead to disease and they may also lead to new treatments for diseases as varied, and we'll talk about them, as inflammatory diseases and as cognitive diseases, developmental diseases, allergic diseases, immunologic diseases. So it's quite fascinating.
There's a lot going on there. And if you go to the supermarket, health food store, whatever, the section on probiotics continues to get bigger and bigger, right? It seems like every year. So Ed, how early does this microbiome begin to develop? And what are some of the critical windows in development that you think of?
Yeah, I think, some people actually think it starts as early as in utero. The data there is not super strong, but has a lot to do with the maternal diet and a healthy diet early through the pregnancy. But I think the time period that we talk most about is the first 1,000 days, is what we call that. The first 1,000 days is the first 3 years of life. That's when you really set your microbiome and get it on the path to be a good symbiotic organism for you. We talk a lot about at birth and how you get maternal microbiome that is transferred to the child and gradually develops and is actively producing things that help to develop your immune system, but also develop your intestinal lining and other areas.
So what about early feeding choices as well for an infant? How impactful is that?
Yeah, I think it's really impactful. There was a great study that looked at hundreds of children where they were comparing breastfeeding to partial breastfeeding with formula to all formula alone. And they found that breastfeeding was really a positive way to form your microbiome and help develop that microbiome so that it can train your immune system the right way. And so breastfeeding, we always say, is the best. It's not always possible to do that. And so, we're coming up with new ways to make formulas more similar to breast as best we can. But there's a lot of benefits to the breastfeeding.
And there's some specific components of breast milk that I think stimulate what we think is healthy microbiome development in an infant.
Certainly. There's quite a few different components. There's just the bacteria itself.
The bacteria itself, yeah.
Yeah, that is providing the bacteria that's colonizing your intestine. But I think one of the things I work on in the lab is something called lactoferrin, which is a protein that helps to boost the microbiome in the intestine and also to help form the epithelial layer. So,
we talked a little bit about going to the supermarket these days and seeing the abundance of, I would say, non-FDA approved type treatments for your intestinal health, right? And that has really blossomed over the last 20 years, which leads me to ask the question about the public conception of the microbiome and what's out there. What do you see in terms of misconceptions or misunderstandings of the role of the gut microbiome in health? And then we'll proceed to talk about what we do know.
Yeah. Well, this goes through the category of nutritional supplements. They're not quite at the moment considered like drugs. So the regulatory arm of the FDA and other agencies has a different supervisory role, let's say. In which case it has been, and it's such a hot topic that many companies have used this opportunity to produce a lot of probiotics. And as you say, we go out in the checkout stand in the supermarket and you got your chiclets and your probiotics. And every week there's a new one. And some are actually quite expensive. I think that we have to be careful because we like to have proof. First, I have to say it was a little bit of a shock to me that a few thousand colonies of a particular microorganism or two would be able to influence a sea of billions, right? It just didn't make sense to me. However, there is some solid data, and we'll talk about that a little bit, that they may be helpful in certain situations, certain conditions. But I think one has to be a little bit careful and understand which probiotics have been tested, how rigorously have they been tested, how big a sample have they been tested. So I usually say they're pretty safe, and if you'd really like, you can try them, but let's try to go with the research and try with the strains that have been tested rather than, the one that's in vogue that particular week.
Adam, you study inflammatory bowel disease, and such an important part of that, of course, is your immune system and how it relates with your gut. And this interaction between the microbiome and your immune system early in life, I think, is fascinating. Could you talk to us a little bit about how you think about that balance between kind of tolerance and lack of tolerance in your immune system early in life, and how important the gut is in that education of your immune system?
Yeah, I think it's actually really fascinating. It's one of the areas that's been most evaluated when it comes to the microbiome and its role in development of disease and other issues. I think, some of the fun and interesting topics that I like to hear about is the exposures, the environmental exposures, and how they affect our development of the microbiome, and then disease, and things like having more than one animal at home is beneficial. Living on a farm is beneficial. This has to do with our exposures to different bacteria during our young age, and so it's these things are considered to be protective against development of these autoimmune disorders.
Some of that exposure is through your gut. Right?
Right. Exactly. I mean, you're gonna eat dirt when you work on the farm,
yeah.
And so that's a major part of it. So that's some of the early epidemiological studies that were done. Now, it doesn't mean that one causes the other, or it's not causative, it's really more correlative. So it correlates with improved outcomes when it comes to that. But it's really made us think about it. And there's two hypotheses. One is called the hygiene hypothesis, which is losing favor a little bit. And now they talk about old friends hypothesis, which is you have to be exposed consistently to good bacteria that train your immune system to turn on the right way. And that seems to be protective against developing allergies, but it also can be protective for other diseases as well, activating immune cells that calm the immune system down. That if you don't get exposed to those, you may not have the opportunity or you miss the opportunity to activate those cells in the right way.
So Ed, you talked about some of the things that may be beneficial, like being exposed to let's say, more abundant or more diverse types of bacteria, like living on a farm. Like, don't clean your fingernails, I guess, before you eat is probably the recommendation there. But let's talk about ways that alternatively could be disrupted, right? What can happen early in life that could interfere with healthy immune system development in the gut?
So exposure to antibiotics. So, of course, there are times when you need to be on antibiotics, even during infancy, that they're life-saving medications. But overuse of antibiotics can play a role in altering your microbiome, which there's a really nice study from the UK that shows in their population that there's an increased risk of developing inflammatory bowel disease based on the number of exposures you've had to antibiotics before the 1 year of age. And so, we as pediatricians need to be cognizant of that and really think through, does this patient really need antibiotics now or not? And of course, like I said, there are times when you absolutely need to be on an antibiotic and there's no question. But there are other times when you might say, let's see where it goes.
I remember reading studies where they actually took normal adults and gave them a broad spectrum oral antibiotic for like a week course, like ciprofloxacin, something broad spectrum, and then actually did molecular studies of their gut microbiome during and for months afterward. And really what struck me was how dramatic the impact is on the balance of different types of bacteria and how long it can be before you have kind of restoration to the composition of the microbiome pre-antibiotic course. I mean, it's incredible.
It truly is. And it's also, I think it's fascinating that diet is similar.
Yeah.
Within 24 hours, if you change from a kind of our Western diet of high animal fat and other things to a more vegetarian or vegan diet, the change is abrupt. It's within 24 hours. And as long as you maintain that diet, you can maintain that healthy microbiome.
Which is actually an interesting question, which I'll pose to you, Jaime, because you talked about, hey, if you pop a couple of probiotic capsules, like what does that do? But they're different, probably different orders of magnitude of influence, right? I mean, so your diet that you're eating every day is probably going to be more impactful to the composition of your microbiome than taking lactobacillus and bifidobacteria in a capsule, right?
Yes, I believe so. I think so far the most lasting or impactful thing that we can change to change our microbiome is the diet. But we are amazingly stable with our microbiome if we don't change things. So that
we're kind of stubborn about our diets, right? I mean, we like what we like, right?
Yes, we do.
but there is probably, so when we talk about what might constitute a healthy microbiome, like when you think about a healthy microbiome and what that looks like, what are we talking about? What are the components of the microbiome that mean it's healthy?
Do you know that answer?
I don't know that answer because it gets very complicated.
It's very personal. It's very individualized. We talk as physicians and as scientists about dysbiosis, and that is kind of what we would consider a abnormal microbiome. But we don't actually know what that is. We know that for certain diseases, certain bacteria being present are beneficial and certain being missing are detrimental. But in the end, we don't yet have a good sense of what is the healthiest microbiome and whether there is one. Because again, we're all individuals. We have genetic predisposition and we have genetic that really does interact with the microbiome.
Is there something to this idea though that diversity is important? That if you have a monoculture, like that it's probably less resilient, less protective. Is there something to the diversity of the different types of bacteria that we have that's important?
I believe there is, but most of the time, the diversity, we use things like diversity and a healthy microbiome, but what the definition of that, of a healthy, diverse microbiome is, I think you would get different explanations right now. I think we're working very, very hard. A lot of people are working very, very hard at pinpointing the different families and genres of the different bacteria, trying to answer that question, because the ultimate goal, I would guess, is that we get to the point where people submit their samples to us clinically for whatever problem they have or whatever problem they want to avoid. And we do the analysis, and then we can very carefully and confidently say, you need this, you don't need that. We've developed this special little medicine for you that has all the colonies and all the prebiotics that you need. And now you're going to have a very healthy microbiome.
Maybe one day.
Maybe one day. Yeah. I think you're right. In IBD, the example of diversity is really critical. I mean, we know that a less diverse microbiome has a higher risk of having IBD. When we compare IBD patients to non-IBD patients, we know that diversity has decreased significantly compared to a healthy gut. So in those situations, diversity is important. But what that diversity is and what that's made of, we still are.
Is there a diversity score?
There is a diversity
There
score.
are statistical diversity scores when they look at the microbiome, but they're pretty complicated statistical techniques that are used to define that. They're not, I think, easily understandable to even the average physician, honestly.
Yeah.
So, Jaime, you moving from the immune system to the neurologic system, this is of great interest to you, is how the neurons in our gut are interacting with the bacteria in our gut and what that means. And I think this is truly a frontier. And of course, the neurons in our gut then connecting with the rest of our neurologic system in our body. So how do you think about that interaction?
Yeah, no, this is actually very, very exciting. And this is a little bit what we're doing in the lab too. So, and I think very relevant to our patients. So we have a lot of patients that have a syndrome, or that suffer from a syndrome that we now call a disorder of brain-gut interaction. This is a bit of a fancy name, but what it means is you're having these pesky symptoms. Some are sometimes quite debilitating, including chronic abdominal pain, chronic nausea.
Me duele la panza, doctor.
Me duele la panza. Chronic abdominal pain, chronic nausea, sometimes either constipation or diarrhea or altering bowel habits. And for many patients, an inability to eat more of a diverse diet. It starts to get more limited, and at times digestion is such a problem and so difficult that they have problems with energy, and they feel very tired, and they can't go to school. So it can be a difficult problem, and we're starting to understand that the brain could shut down the gut. Certainly, if the fight or flight, if you're in Africa and a lion's about to eat you, you see the lion coming, it's not the best time to digest your meal, right? Your brain will immediately tell your gut it's time to abort. If you have something in your stomach, you'll probably vomit.
Sympathetic system kicks in.
Absolutely. Yeah. If you have a lot in your colon, you might have an accident in your underwear too. And that's totally normal and understandable, right? So that you want the brain, the big brain, to override and to speak to our second brain. The 500 million neurons are contained in the gut. But so many of our patients seem to have a little bit of something's wrong with this language between the great brain and the gut. And when there's no true, inflammation or alteration that we can detect with our normal exams, even endoscopy, why would people be feeling so bad? And sometimes it's really bad. I mean, it's striking how affected they can be. I think
many of our listeners probably have those patients in their practice at some degree, right?
Yes.
That's super common.
Super common these days, super common, and can cause a lot of morbidity. So we did a test in our lab, and we gave mice, adult mice, 4 different antibiotics. This antibiotic cocktail eradicated most of the microbial component of their microbiome, or the bacterial component. And well, we were amazed to see they had terrible GI motility. But then when we looked at the neurons, they had decreased anywhere from 20 to 30%. Strikingly, there were less neurons after the antibiotics. And what was even more striking is when we allowed the mice to replenish their microbiome, we took away the antibiotics and whether just let them be and eat their normal chow and the bacteria in their cages, or we did a stool transplant, it didn't matter. But a few weeks later, the microbiome was back, and so were the neurons. The neurons came back. So that was striking to us because it means that there is neurogenesis. We've been saying that, and other people too, in our adult guts, sort of just like in our adult brains. And at least in the gut, it seems like it's the microbiome. It's those bacteria that are in charge of the trophic function of the neurons and of making them come back and replenish when we need them again.
And it seems to be kind of adaptable to the environment, right? The neurons came back relatively quickly.
They did within weeks. Within weeks, we had them back. So it was really striking. We're trying to understand, obviously, the mediators and the type of neurons and all this.
And then how do you translate that learning to the patients that you're caring for? How do you think about that?
Well, I like to tell them that what they're feeling, there's a lot of evidence in the lab that it's very real. And although the tests are normal and people probably have told them that it's all in your head or you're imagining, it's not true. These are very well-described syndromes, and we're understanding more and more what happens. And I wish that I could tell them exactly what bacteria are missing. We can't do that yet, but we do believe that the things that make a healthy microbiome are likely to help them. And what is the evidence that we have for a healthy microbiome? Well, sleeping adequately, exercising, a good amount, a healthy amount, and eating what we believe is a healthy diet, which is less of the processed foods, more fruits and vegetables and fiber. And
do you think it's ironic that, so thinking about one of the syndromes that falls into your camp, which is irritable bowel syndrome, that there's actually an FDA approved indication for antibiotics for one of the subtypes of irritable bowel syndrome. So do we have any idea what we're doing? or is it just that you're maybe altering the microbiome in a way that's favorable in certain patients that may benefit?
And very good questions, Dave. And what are you going to do? Keep on giving the antibiotics every 3 weeks? Because we know that the microbiome comes back and we're fairly stable at it as long as we keep our diet and our habits. Yeah. So
I don't know. That doesn't sound great to me, but
Is this a place where probiotics might be helpful?
It might.
Because I was thinking about your antibiotic example, and that's the one area where probiotics have been shown to have some benefit for antibiotic-associated diarrhea, and so and recovery of. So I thought, maybe that's a place.
Well, I'm excited. I think things are changing, and I think that we're going to have much better answers in the future, and much more personalized medicine, perhaps through this.
Yeah, and to that point, switching back to the inflammation in the gut, Ed, what's being explored in terms of microbiome manipulation in inflammatory bowel disease or other autoimmune diseases?
Well, you brought up the example of IBS. I'll just kind of touch on that real quick. We talk about the low FODMAP diet, which we also talk about prebiotics as being a benefit. Prebiotics and low FODMAP diet don't agree.
Right.
And so we're still confused as to what thing is the best for us, right? That's just one example. But as far as treatments for inflammation in the intestine, sometimes antibiotics can be very beneficial. But also we talk about prebiotics and a healthy diet. Again, dietary fiber being really critical. And dietary fiber has been shown to increase your short-chain fatty acids, which have definitely been shown that they can benefit the intestine overall. And that's short-chain fatty acids are produced by our microbiome and help to, again, mold that immune response to be more regulated.
And one of one of the things that's interesting to me about the treatment of Crohn's disease in particular is one treatment that isn't used commonly because it's hard to maintain adherence is this idea of what we call exclusive enteral nutrition or EEN, which can have reasonable remission rates. What is going on there in terms of being able to heal Crohn's disease for the short term, at least?
The theory is similar to what we talk about with the microbiome in general, that diet affects your microbiome. So in this situation, in Europe and in Canada, they use it as exclusive, so meaning nothing but formula.
So you typically at diagnosis, right? You go straight on formula for a period of time, no food.
Right. And it can be very successful for Crohn's disease. It doesn't work so well for ulcerative colitis, but it does work for Crohn's disease. And when I say very successful, better than some medications sometimes. The hard part, as you pointed out, was maintaining exclusive enteral nutrition. And we talked about the fact that your microbiome goes back to what it was. We know that if you stop exclusive enteral nutrition, within 6 months, you'll have that microbiome back. But it's interesting because what it seems to be doing in IBD, which is different than what we've been talking about in diversity, there's studies in Ireland that show that it decreases the diversity of the intestinal microbiome, which is fascinating. But it must be that those are helpful bacteria or more, what we commensals, the good bacteria.
And I think also when you say antibiotic use could be helpful, I think the problem is most of our antibiotics hit many families of bacteria. But if we could be more targeted, right? Yeah. And that's what we hope.
And that's where a lot of the research is going into ways to target specific bacteria.
Yeah. So I think one of the things that I'm appreciating from this conversation is that we have a lot to learn about this organism that lives within us, how it impacts our health. We may not truly understand a lot more than some of our families understand, right? And so that gets to the conversations that we're having in clinic with our families, because we get a lot of questions in gastroenterology about this specific issue, which is probiotics. Yeah. Should we use those? Do they help with just sustaining good health? Are they useful in disease? How do you guys approach that conversation with families in a way that balances, I think, our responsibility to the families, but also the humility that there's a lot we don't understand? How do you guys have those chats?
I think you pinpointed the answer that I use, which is there's a law we don't know. There's a law we're finding out. I'm very happy to share with you the diseases that we believe where probiotics might be helpful and which particular probiotics have been
like
tried.
Antibiotic-associated diarrhea, for instance.
Absolutely. However, for things like feeling better, preventing diseases, preventing allergies, I mean, the data is a little bit weak. It's actually much weaker. I see a lot of constipation. For preventing constipation, treating constipation, if they really want to try, because I think it's a fairly benign thing, I say, okay, just try not to break your piggy bank, because some of those treatments can be quite expensive. But if you want to give it a try, and anecdotally, I hear that it has helped. Can I say that that's better than placebo? Of course not. I can't.
Right.
But if it's helping and the family's okay with paying out of pocket for that, I usually have no problem. But I do confess that we just don't have the data yet.
And how about you? I mean, you have the complicating fact that many of your patients are on immunosuppressive therapy of various kinds. So how do you have those conversations around manipulating the microbiome?
I mean, I have a similar conversation. I talk a lot about these are generally not harmful. I also do bring up the point that things are very strain specific. So you want to make sure you're getting it from a reputable source. You want to make sure that it's a strain that actually has been shown to have some effect. Because if you look in the grocery store, you'll see all different kinds of probiotics, and it may say lactococcus, but it's not the same lactococcus between different probiotics. So you don't know for sure which one. And we can do the research to try to define if there's any strain specific benefit. The other thing I do, there's a group of probably 3 types of patient that I would not use it in. If you have a central line, I don't think that's a good time to use a probiotic. Not necessarily that we see translocation of bacteria, but it's more, it gets on your hands, it gets on the, and you're changing the line or whatever it might happen. As clean as you can be, it still is a risk. I think severely immunosuppressed, our patients are immunosuppressed, but they can tolerate a probiotic. They can tolerate the bacteria that are in their intestine. And then I would say, I would say probably in that group, it's cancer patients that are undergoing immunosuppressive therapy or bone marrow transplant or other things. I think that's an area where you really need to talk to your physician about that.
So as you guys think about the next few years of research in your labs in particular and how you're studying this, what are you most looking forward to about discovery in this space? Ed, let's start with you.
I think a better understanding of what bacterial subtypes or strains are beneficial. I think the area that people are going into a lot is synbiotics. So, we talk about prebiotics, probiotics, antibiotics, but there's concept of synbiotics where you provide a type of a prebiotic with a bacteria to kind of boost its growth and boost its ability to stay alive.
You feed the bacteria.
You feed the bacteria, right? As you're giving the bacteria.
Yeah, that makes sense.
So I think that's an area that's very interesting. The other area that I think is really fascinating, we're not working on, but is bacteriophages. And because we know that there are bacteriophages in our gut, these are viruses that attack bacteria. And so that's a way to really target something very, very specifically. If we wanted to get rid of a type of bacteria, that could be used
rather than an antibiotic.
Right.
Yeah.
Right.
Much
Exactly.
more targeted.
Much more targeted.
Jaime, what about you?
Well, I'm going to share a little bit of that yes, I think that typifying exactly the type of bacteria that we need for the nervous system as well, for the trophic effect and the better improvement not only of our gut nervous system, but our brain nervous system. It's incredible that there's some data that the microbiome may even affect our behavior, our mood, our sleeping habits, our pain threshold. So I would be we've been hearing it, for example, from a lot of parents with kids with autism for many years, that certain foods don't agree with them and that their symptoms, particularly sometimes aggressiveness, sometimes pain, is very different than neurotypical children. So how can we understand what products and what bacteria are mediating these effects so that we could better modulate, for example, if it's visceral hypersensitivity, and I just told you that new neurons are produced. Are there too many sensory neurons that are produced at some times? Can we modulate that effect? Can we improve not only digestive symptoms and nutrition, but also general pain, general inflammation, cognitive? Could we prevent neurodeterioration, neurodevelopmental, and diseases such as Parkinson's, which apparently starts in the gut? Amazing questions, right? Amazing. It's a wonderful time to be a scientist these days.
Yeah, amazing future. Happy you guys are leading efforts in this space. This has been a really fun conversation. Thank you for joining us. I was thinking about a cheeseburger tonight. And now I think a salad may be a better idea, not just for my heart health, but for my microbiome health. So
broccoli's delicious.
Maybe a little fruit too. Add a little fruit
maybe a little fruit to that. Yeah. So thanks guys for joining.
Thank you.